Hello everyone, so we're going to go over how to go from a table to function, but this time in real world situations, meaning from a word problem. So again, we're focusing on real world situations. So here's our first one. A submarine is traveling at a depth of negative 300 feet, so it's underwater. It begins ascending, meaning it's going to go upward. Let's write that down. At a rate of 28 feet per minute. So let's go ahead and take this information and translate it into the table and then write our function that represents this situation. So let's go ahead and get started. So quantity, when I say quantity, is what are we talking about? Height, time, whatnot, depth. It can be anything here. In this case, we're talking about the time it takes for this submarine to be traveling, and in this case, the depth of the submarine. How deep underwater is this submarine at a certain time? So our time is specifically in minutes. It's not seconds, it's not hours, it's not years. We're talking about minutes here. And the depth is in feet. So it's not in inches, it's not in yards or any other unit. So we can see that in our table, it's changing at a rate of 2, the input, which means we have to make sure we take that into account as we figure out the output values. But first of all, where are we at time 0? So let's read the sentence again. A submarine is traveling at a depth of negative 300. So that means we're starting at negative 300 feet underwater. And after 1 minute, we know we've traveled 28 feet. After 1 minute. But here in this table, we're going off of 2 feet. So we have to calculate how many feet that is. So in 28 is 1 foot, 1 minute, times 2, because we're talking about every 2 minutes, that's going to be 56. So we're going to be adding 56 to each row in the table, because we're going upward 56 feet every 2 minutes. So negative 300 plus 56 would give me negative 244. You add another 56, will give us negative 188. You add another 56, you get negative 132, which is already here for us, and then negative 76. So let's fill in the left side. It will be 6 minutes. 2 more would be 8 minutes. Now the next one is where we're going to write our function. We're going to use t as our variable instead of the variable x, because we're talking about time. In this case, we're using our function f of x from last week equals mx plus b. In this case, we'll probably be using a different variable based on the word problem. In this case, we'll be using the letter t because we're talking about time. And I know I'm starting at, let's use a highlighter for this one. I know I'm starting at 0 is negative 300, so I'm going to put minus 300 back here. And then my m value, which is my slope or my input over output, output over input, which is me dividing this number here with this number here. So 56 divided by 2, which is back to that 28 from earlier. So that's going to be my m value, or you could have just gotten it from here directly, 28 feet per minute. So my function is d of t, so d for the depth at any time, is 28t minus 300. I'm going to take this expression and put it here. So for my function, the right part of my function is my expression, 28t minus 300. And this will allow me to calculate at any given time. Let's go ahead and clear this out and move on to the next problem. Number 2. So we have a free diver is diving from the surface of the water. So surface is important at a rate of 15 feet per minute. So quantity is the same here again. It's time again. And the depth of the diver at a given time. And again, we're talking about minutes again and feet. So let's put minutes and feet. Alright, we're going to go ahead now and fill in the table. So at the very beginning, diver is at the surface, so we're going to put 0 here. And every minute he is changing his depth by 15 feet, so he's going underwater because he dove into the water. He's not ascending, he's descending in this case. And on the left side of our table, we're checking his depth every 1 minute. So in this case, we have negative 15, negative 30, negative 45, which is given to us, negative 60, which is also given to us, and we just fill here 3 and 4. And we're going to put as an expression of t for time. So we know that every 15 minutes we divide by 1, and that's going to give us negative 15 for our m value, for y equals mx, in this case t, plus b. So my b is at 0, the 0 start value. My start value is at 0, so I'm going to put plus 0. Now this 0, because it is a 0, you don't really have to write the 0 down if you don't want to, but I just wrote it down for this case. So now we're going to go ahead and write our expression. Remember, this one goes here. I'm just going to write negative 15t. I'm not going to put the plus 0 this time. Let's go ahead and move on to the next problem. Let's go to number 3. So a backyard pool contains 500 gallons of water. And it's filled, so we're putting water into the pool with more water at a rate of 6 gallons per minute. So in this case, what do we have going for us? So this time we have quantity. Our independent quantity, again, it's time, and we're still in the minutes. And the dependent quantity, well, what's happening every minute, the amount of gallons in the pool is changing. So here we're going to be talking about water in the pool, and then it's going to be specifically the gallons. So our values are going to be how much water is in the pool, and it's going to be measured in gallons. Alright, so at the very beginning, how much water is in the pool? So backyard pool contains 500 gallons. That's the starting value. And we know that something is happening every 1 minute. So every 1 minute we're getting 6 gallons per minute. So we have 6. So we're adding 6 gallons. So we're going to have 506, 512, 518, and 524. And that's at 3 minutes and at 4 minutes. We're adding 6 gallons. So my function is 6 divided by 1. I'm write 6 over 1 again. I'm just writing it down so you can have it in your notes, but you can probably do this in your head. 6t. And it's positive because we're adding it to the pool, plus the beginning value. My beginning value was 500, so we're going to add 500. So this is my expression, which goes right here. So 6t plus 500. And expression is t for the independent quantity. And let's go ahead and do our last problem, which is here. Actually, let's move this up a little bit. There we go. Alright, so we have a helicopter is flying at 3,505 feet. And it begins its descent. So it's going down. It descends at a rate of 470 feet per minute. So again, this is going down. So our quantities, independent and dependent. So what's happening? We have time again in minutes. And what's happening? It's the height of the helicopter is changing. So the height, we're measuring it in feet. And we're going to go ahead and fill in our table based off that information. So at the very beginning, we're starting off at 3505. And what's happening, let's see, on the left side, we have every 1 minute. So it's 470 per minute, so per 1 minute. So it's going to be going down, so it's negative 470 per every 1 minute. So it's going to subtract 470 each time. So we get the following number. So we subtract first 470, we get 35. We subtract another 470, we get 25.95. Minute 3, we subtract 470 again, we get 20.95 again. I believe this is a typo. This is 65, sorry, and this is 95. And minute 4, we get 16.25. Alright, now for our function at time t, which can be at any time. So we know our slope is negative 470 divided by 1, so it's negative 470. It's from our change, negative 470 over 1, which is just negative 470. We put our t value, and then we put our starting value, which is 3505, so plus 3505. And I'm just going to take this and rewrite it there. Negative 470 t plus 3505. And there we have it. So these are just examples of how to translate from a word problem to a table to a function. So you can also be asked to graph these, and then you have to set up your graph. Same idea as last week. So go ahead and get started on your practice pages, and good luck.